Welcome back, class, to Chapter 3.1, Solving Equations Using Addition and Subtraction. So, the main concept. To change or transform an equation into an equivalent equation, think of an equation as having two sides that are in balance. So it's very important when we're going to solve this. In the end, we're going to solve this equation. But it's very important you understand that this side does equal the other side. That's why it's so important that you check your work. Because if you plug it back in and it's not balanced, then you have the wrong answer. Okay, so we have to have an equation in it's going to be equivalent equations. Okay, so the left side is going to equal the right side. Okay, so that they are balanced. So how do we do that? How do we solve for x? X plus 3 equals 5. We could probably guess in our head what x is equal to. But now what we have to do is we have to show your work. So how do we find out what x equals? Well, what we're going to do is take the inverse operation. Okay, so inverse operations are operations that undo each other, such as addition and subtraction. Inverse operations help you to isolate the variable, and this is the most important thing in algebra. Okay, our goal is to get x alone. So when we look at this equation that we had before, I'm going to rewrite it over here. Okay, how do I isolate the x? How do I get x alone? Well, I take the inverse operation. So when I see the value of this 3, it's a positive 3. It's addition. This sign right here is addition. So how am I going to get rid of this 3? Is I have to take the inverse, the opposite operation, and make it a negative 3. I'm going to subtract 3 from both sides. Whatever I do to one side, I have to do to the other side. Come on, erase there. There we go. Alright, so that, remember again, we're isolating the variable. We want x alone. So when we do combining like terms now, well, 3 minus 3 is 0. So that crosses off. So I have x alone here. And then 5 minus 3 is 2. So I know x equals 2. I plug it back in to check. 2 plus 3 equals 5. And that is true. So this equation is balanced. You know what, that was originally on the screen, so I can't erase it. So 2 plus 3 does equal 5, and it is balanced. Okay, so every equation that you'll answer tomorrow, okay, we have to check to make sure that it is balanced. So here's some more examples. So x minus 5 equals negative 13. So inverse operation, this is subtraction. So we're going to add 5. So when you combine x minus 5 plus 5, these 5s cancel each other out. And now this goes back to what we learned in Chapter 2, negative 13 plus 5. Different signs, so we can subtract them. We know this number is going to be negative because 13 is larger than 5. So 13 minus 5 is 8, so we know it's going to be negative 8. Okay, so when we plug it back in, negative 8 minus 5 does equal negative 13. So our balance here, okay, is equal. Okay, not one side is tipping the other side. Okay, it is perfectly balanced. Maybe I should have drew that the other way, now that I'm thinking about it. So we know it's balanced. It's a little crooked balance, but it's balanced. So negative 8 equals n minus negative 4. So the first step here I would take care of is this. You want to make sure you change that, because we know two negatives next to each other is going to equal a positive. So change that first before you solve it. So now you take the inverse operation. This is a plus 4, so we're going to subtract 4. So negative 8 minus 4, they both have the same signs now, so we're going to add them and add that common sign, so negative 12 equals n. So now that we know negative 12 plus 4 equals negative 8. So our equation checks out. It is balanced. Okay, there's not one side teetering more. They're both negative 8. Another example. Several record temperature changes have taken place in Spearfish, South Dakota. On January 22, 1943, the temperature in Spearfish fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. So think about that. Just within the amount of time, look at the amount that has fallen. Okay? Look at the amount that it fell. So, by how many degrees did the temperature fall? Now we have to write an equation to show this. Okay? So we know that the original temperature was 54 degrees Fahrenheit. We know that when it was ended, when they wanted to test it again, it was at negative 4. Within that 20 minutes, it got from 54 to negative 4. So how many degrees did the temperature drop by? Sorry about that. So 54 degrees Fahrenheit plus x equals negative 4. Alright, so one more mistake that I made. There we go. Alright, so 54 degrees Fahrenheit, and it fell. Okay, so we know it's going to be negative. Minus x equals negative 4. So how do we get this to the other side? Is we subtract 54 degrees Fahrenheit over to negative 4 degrees Fahrenheit. And we know that negative x equals, okay, now negative 4 minus 54, same sign. So we know it's going to be negative 58 degrees Fahrenheit. Now, x can't be negative. So, we divide by negative 1. We know that x equals 58 degrees Fahrenheit. So we know when we plug it back in, we started at 54 degrees Fahrenheit at 9 o'clock. It dropped, it fell 58 degrees to give us the negative 4 degrees that it ended up being at 9:27. Okay, so be careful of the sign that's on the x. Okay, our variable can never be negative. Okay, in the end, it always has to be positive. We have to isolate the x by itself, and it always has to be positive. Okay, now if I would have left it as negative 58, you would have plugged that back in, and you would have noticed that it doesn't work out. Okay, so always check your answer, check your solution. So here's your homework. X minus 9 equals negative 17. X minus 9 equals negative 17. 2, negative 11 equals n minus a negative 2. 3, 5 plus x equals negative 3. And then 4, you find $10 on the sidewalk and put it in your pocket. Later that day, you empty your pocket and you find that you have $28. How much did you have before you found the $10? Write an algebraic equation to help solve. Not sure why that's there. So, write in, not in and, sorry. Write an algebraic equation to help solve. Okay, so tomorrow I should see all of the work for 1 through 4 in your homework binder. Not your homework, I'm sorry, your note binder. Okay, I will check that tomorrow. Alright, I hope you have a wonderful evening, And if you have any questions, please contact me, and I'll talk to you tomorrow. Take care.